Hello everyone, in today's video I want to show you a cool trick I've learned where you can take a whole bunch of image for computer vision task and then process them to be able to view them as a cluster in a scatter plot. So basically what we're going to do is we take the image, we vectorize it using a neural network, and then we use a UMAP or TSNE or whatever it is to take the high dimension and put it into 2D or 3D. So let's get into it. So most of the code that I've took out in the strategy is from this notebook that I will link up. It's pretty cool, but it took me a while to understand what the heck they were doing in there. But the great thing is at the end, we get like a map like this that is interactive, and then you can see, let's say, all of the data in there, the image. So we're gonna refactor this in a more readable fashion. Before I jump in, the main idea here, like I said, is to take the set of images and then to have a cluster that is like this. The main rationale on how this is possible is there's a neural network that are already pre-trained for computer vision tasks, and you're just gonna feed them an image, and they're gonna kind of probe one of the layer activation, and this activation will be your vector. So you go from a bunch of pixels to just a bunch of a vector basically in one of the layer. You can select which layer you want, but for our use case we're just going to use like one of the last one. That strategy is from a paper called Img2Vec. Good paper. I will link it to the description. There's a guy named Christian Safka. He already made like a package a Python package to literally do that. So we're going to be able to use that, and there's a whole bunch of model that we can use. I will use the ResNet 18 to reduce the dimensionality. We're going to use a UMAP. So basically it's uniform manifold approximation and projection for dimensional reduction, but it's the same thing as TSNE or PCA. Like it's just one format of it that work really well with this type of data. Also linked into the description this strategy, but in a nutshell this is what we're going to do. So that's the pipeline, a whole bunch of stuff, but we're going to see the data we're going to use in there is Aero Engine data. So basically it's a whole bunch of kind of rotors and stuff like that that are damaged. There's a few damage, and like a bunch of people like took a picture of them. The interesting part with this is that there's a whole bunch of defects, so scratch, dent, whatever of rotor. It's all rotor, but the cool thing is that the images are all different. There's like 3 data sets that were combined. So we'll be able to see all of this in our visualization. So let's actually get into it. So here am I into the Kaggle notebook. So you can see the data is here. We have the image. There's a train, a validation set, and then there's a bunch of label. So I'm going to use all of this. So this is the train image, and then there's a label that are right there. The label is a bit weird. It's basically like one file per image, and then there's the damage type, and then there's a whole bunch of coordinate here. We're not going to use most of this for this thing. We're just going to use the damage type and then the image. The rest is just like not that important. If you look at the actual library, Img2Vec, how it works in a nutshell is like this. Like, so you have you import it, so Img2Vec PyTorch. And then you have you initialize the model you want. You can say exactly which model you want, and then you open an image, you jam it into this model, and you say .get vector, and then you get the vector. And if you want to have multiple vectors, because there's a whole list of image, you just do get vec again, and with a list of pill image. So it use pillow, it use Img2Vec PyTorch. Yeah. Alright, so the first thing we have to do is actually install install the library. It's not a native library for data science or something like that. So there's a specific syntax for a notebook we have to set, and then yeah, this will just print it. Okay, so now it's supposed to be saved, and then there's a whole bunch of stuff we're gonna do. The strategy here is to follow a bit this pattern that we have here, where we read an image in RGB format, and then we fed it into this this particular thing. All right, so first step here, we installed it. Now we need to import. So from Img2Vec PyTorch import Img2Vec, exactly like we were doing it here. Here, by the way, it's a markdown thing. It's not an actual not actual code. So Img2Vec, and then we can use this syntax here. So Img2Vec G2Vec here, and then we create the Img2Vec model. So no GPU, and the model is ResNet 18, right? Remember, there's a whole bunch that we could use, but we're just gonna get that. And then here it is. So this is the Img2Vec motion. Here we go. Now we need to feed it a bunch of image, right? In order to do that, before we have to actually get the path to the image. So in our particular case, image path is this. Is there a way to get it? Okay, here. I want that. Okay. There we go. And then we're gonna put a little star here because we're gonna like recursively get the image afterward. So this is where we're gonna get all of our image. We're not gonna go through the validation picture. We're just gonna go through the training pictures. So let's iterate a bit through that. In order to do that, we're gonna just use a simple for loop, and then we're gonna use something called glob. There we go. Right. This thing, we need to import it. So import glob from glob, import glob. So glob is just a way to, it's just a library that we're using in order to properly traverse like a file path. So if we look at this and we iterate here, we're going to be able to get all of the file that are in there. All of them, we can traverse them. And why is it iterating like this? Is simply because I've put a little star here. So I gave this this path to glob, and glob was able to go ahead and make me every file, everything that is in there. And I'm just printing the path here. So the first thing after that is to actually get the name of the file. We're gonna do some basic printing here. Okay, tag, and then we're gonna print it, image, file, name. So we're just getting the end of it. So now we know what are we actually processing. So F string. F string are just an easy way to format string in Python. Processing file. So then I'll know exactly where I'm at, because there's going to be a whole bunch of stuff we're going to do. So remember, what we're trying to do right now is using this model, iterate on every image, right? We're going to want to take the image, jam into a model, get a vector out, right? And then store that vector so that we can do the UMAP thing afterward, right? In this particular case, if I have to, this will be the UMAP from a vector to like to the features, and after that is going to be like 2D features to interactive visualization. In this case, we're going to use something called Bokeh. Okay, so if we go back here, now we have the image, and now we just need to actually open it, because we actually want to do something with it. So here we're going to use Pillow, and Pillow is just a library where you can process image pretty easily. So we need to import it. So from Pill import image. There we go. Actually, like these to be like this. So then the format here is simple. It's with image.open, and then we have our image file path, right? File path, not file name, and then as image, right? And then here there's a bunch of stuff you can give to open, but here we just want to read it. We don't want to write on the image. Once you have that, then you literally have the image, and you can do something with it. And in our case, what we want is to get the vector from the open image. And to do that, it's this syntax here. Img2Vec get vec. But our thing is not called Img2Vec, it's called model. So we're gonna do model get vec, and then we're gonna do image tensor equal true, right? Just as here. And then we're gonna do yeah. For now, this is good enough. If you look here, right now, it's going to take a bit of time in order to process. If we want, we can print this out to see what it look like. But it's a PyTorch tensor basically. It's good. It's good. I don't want actually a PyTorch tensor. What I need here is for this particular purpose, what I want is to get my my big tensor, put it into just a bunch of numbers, right? And have, let's say, something very flat. This is not flat. If you look at the shape of this, if I import NumPy here, I do a NumPy dot shape the vector. It's gonna have, it's actually a tensor, so it's gonna have like a bunch of different. It's a 4-dimensional tensor in PyTorch. So I have as one dimension of size 1, one dimension of size 512, one other dimension of size 51, and another dimension of size 1. If you remember, the 512 is because we're using ResNet, because that's the last layer. That's how big it is. Cool, but I don't want that. So what I want here is to just flatten this whole thing. So I want to like have a NumPy array here, and then reshape that to a 512, right? And if I do that, I can just do a NumPy.shape, and you'll see it's gonna be flat. It's 512. This is good because it means that I have like a one-dimensional vector. I don't like to have hard-coded variable here, so I'm gonna say vector size equal 512 here, and I'm gonna put it here. Test if it's still working. Yes, still working. These are my experiment variables. Okay, it's starting to take shape. Now I'm literally having a vector over and over again that I'm processing every image and putting them into a vector. If you were to look at each of the of the number, it will be all different numbers. Now, what would happen afterward is I'm gonna put everything into a data frame. So the best way to do that and to put a data frame is just to have like a list of I prefer always, if I'm processing stuff, I will always prefer to either have it already in Excel and just load it and put it into my data frame, which is kind of the best setup. But right now, since I'm going to do it one shot every time, I'm just going to take a list and make a dictionary out of my whole thing. So if I go back at the end here, what I'm going to do is this. I'm going to do vectors data equal append, and then put my stuff. Oops. Put my stuff in there. So I will create a dictionary for every file that I'm processing and jam the vector in there. Here I'm gonna put the file name. I'm gonna put my vector in there. I'm also gonna put the file path, I guess, just in case I need to use that afterward. And that's kind of it. So we're doing great here. I'm using a width here just so that I can close the image, because there's a lot of image. I just don't want them to be open all the time. Okay, so we're good here. And then what I want to do next is to mess around with the labels, because right now you don't, as you see here, there's only this that is getting created. Like, yes, we're processing a bunch of stuff, but I don't know what label each of the stuff are. And if I want to have a good visualization about my things, I want to be able to say this is that label and this is that label, and color them a bit differently or something. So I want to be able to extract the label information. So this is a dictionary creation. Go, perfect. So yeah, if we look here into my labels, it's another, it's completely in another path. It's over here. So I'm gonna do the same trick I done here. So labels, path. So I put it all cap because it's a static variable. And now what I can do is, instead of trying to find the path or then doing a merge, I'm just gonna like do a bit of a string replacement, and then we'll be good to go. So basically, label file name equal image file name that replace that GPG to that txt. Right, you see this is txt file. The other one were like that GPG file. So I'll just replace the two, and we'll be able to directly find the right stuff. And then I'm going to do a label file path equal, just construct this path, labels path plus label file name. I didn't put a star here because I'm not going to use glob to kind of find all of the stuff and recurse. I know exactly which one I find, and here it means that I assume that the data set is clean, which is it's not clean, right? Some image don't have .txt file, so I have to account for that, right? If I have to account for that, I'm going to use well, actually, let's try to open it. You're going to see what I mean here. Yeah, like this, and then new line. I'm just going to open that. Let's say there's a new line here. And then it's as a CSV file, but as you can see here, it's not directly a CSV. It's like a TSV, tab separated value file. So you just need to kind of go around with it and open the file. So I'm going to do a reader here, CSV reader, CSV file, and my delimiter here is a tab, like this, and that should be good to go with that. As I'm gonna do this, I should get a bunch of error. No social file directory. You see here, train. Oh wait, no, this one is messed up. I think I messed up this. Okay. Okay, you found this one, this one doesn't exist. I think that's the issue. No such file, train 15.1.txt. If I look, 15, there's no 15.1, right? So I have to kind of account for this before I go in there. Thankfully, I can just use, I can just test for the existence of a file. So I can do os.path, and then the exact syntax is os.path.is file, and then I can give my label file path. And if this is false, I'm just gonna print it for now. So okay, test it out. You see, date blah 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 doesn't exist, because I tested it with os.path.is file. I'm just gonna do label file name. I don't need to print it every time it doesn't exist. Right now what I'm gonna do is I'm just gonna go continue, and continue what it does when you're in a for loop. You just go back, you just skip everything and you go back to the next iteration. So now this thing should just run, and like it will point me to where it doesn't exist. So 5.3.txt doesn't exist too. This one doesn't exist. Whole bunch that doesn't exist. It's all good. But now I can actually do something with this and actually read the file. To read using the CSV reader, I just need to do next, and then it will collect me the stuff and output it to me in a list. So if I print that, and this I think is because it's an iterator, and an iterator, it's like something that will chunk your stuff into like the bucket that you need, and every time you call next, it will pop one out. And in this case, the thing that will pop is a full row. And the thing with this specific CSV file is the row is the only thing I need, right? See, I pop it up and they will pop me a list, which like this is the label, this is the coordinate that I need. So since it's a list and it's well made, I can just parse it out directly. So I can do label W0, W1, W2, W3. The W's here are just the name of the coordinate that they're using. Like I said, we're not gonna use these ones, but I'm just gonna pop them out for completeness purposes. So we should be good here. And now I can just put that there. I'm gonna put this label. I'm gonna put W0. 1, 2, and W3. Okay, so we're getting there. That should do the trick. It will say a bunch of stuff. What I'm gonna do afterward is, once I have all of these vectors data, I'm just gonna jam it into an actual data frame, a pandas data frame. So I'm gonna need panda. So import pandas as PD. Is there any error here? No, cool, no errors. So this is good. I'm just gonna disable this print statement, but because I don't need that much printing. So this is a bit more silent now. Whoops. Like this one. And now I can actually use my panda data frame, and I'm gonna put the vectors data in here. I'm gonna name this train df, and I'm gonna do I hate it when it does that. Create the data frame using the list of dictionary. And then I can actually see it. Yeah, this one. Perfect. So you see, I have my image file name here. This one, file path, the actual vector of a 512 dimension, the label, and then these. This is getting there. One thing I need next is there's a whole bunch of like these labels are not that useful if it's tree one and whatnot. So I'm just gonna change them, and I'm create something called class, and then I'm just gonna map them out. Right. So if I remember correctly here, okay. So 0, right, is called scratch. So this is a scratch image. So there's a defect, which is a scratch on the image. 1 is that there's a dot on the image, so it's a type of damage. There's a crease for 2. This, and the last one is it's a more general type of damage. Train df, and then we map them. See, 3 damage, 3 damage. I have to put like, it's not actual numbers here, because remember when we did that here, we just took the text, we didn't transform this into an integer or whatever it is. This is good. I'm just gonna store the label path, label file name, and just for completeness purposes, because I may need it afterward. I don't think I'm gonna need it, but like, you never know. You don't want to run this thing too many times like I'm doing right now. Okay, this is going good. And now we finished the first step, which is taking an image and put it into a vector and jamming it there. Yeah. Okay, now that we have the vector, let's set up the UMAP. Thankfully, there's actually a library that implemented UMAP directly. So thank you, Leland. The library is over here, and it's a well-known library, a lot of stars in there. It seems to be working quite well. So this is actually what we're going to use, and we're not going to implement anything from scratch. So first thing first, from UMAP, import UMAP, and then we're going to use a 2D version of it. The syntax is pretty easy. So we're going to initialize random state. This can be absolutely anything. Let's put the current date. We're going to set it to verbose. There's not going to be like some parallel computing stuff we're going to do. False, and number of epoch we're going to use is 2000 here. That's the kind of the base parameters that we have. Then there's a bunch of other parameters that are interesting. In this case, there is the how's it called, the M components, and if you put 3 here, it will give you 3 components. In our case, we want 2, but this is a default. And then there's n neighbors, if I remember correctly. And this is an interesting one, right? So the neighbor actually it's a way of like balancing in the manifold how many of this little dot they will take into consideration to set up the neighbors. By default, I think it's like 15. But as you change these parameters, the visualization is different, right? So you kind of need to balance it out with what you think is most helpful for you. I'm going to take N50 just so that we are a bit more dense. I've tested it out before, and it's good with N50. So this is good. Is it no, it's not. Made a mistake. Yeah, it's just that I don't know how to write properly. Okay, perfect. So at this point we created our UMAP model. Now we actually need to do something about it, and we have to actually transform our data set. So the way to transform that is, I'm gonna not change too much. I'm gonna use jam my vectors in there, and then get back an x and a y, which will be the coordinate, and just put it back into the data frame that I have. So UMAP2D dot fit transform, right? So this is kind of the sklearn type of syntax. By the way, this library is made by the guys that made the paper, so actually it's a good one. PD series. So what I'm doing here is I'm going to take my vectors and I'm going to transform them into pandas series. That should work. Yes. Starting up, and I can put it here. So it was actually quite fast because my data set is not that big. So here, like what I'm doing basically is I'm taking all of my vector column, right? And that's what I'm gonna give to my as a data set to my UMAP, and they will use that to figure out like how to take this height, this 512 dimension, and put it into just 2. So just gonna run it again just because I want to see when I'm done. And it's over here, X and Y. You see, I have these. So now, like we're already kind of done with the image to jamming it to the ResNet, getting a vector out, storing it, and taking this vector and doing a dimensionality reduction on it to get 2 coordinate. The only thing that we need to do now is just to visualize it. So for the visualization, what we're going to use is something called Bokeh, which is cool because it allows us to have some interaction with the plots. See, like this. Yeah, just find that it was a cool library, so we're going to use it. So from Bokeh models import, we're going to import a whole bunch of stuff. Honestly, I didn't find it that intuitive as a library to use. Well, compared to a bit old school, but like Matplotlib and stuff like that. But still, it creates some really cool plot. So we're gonna bear with it. So the first thing we need to do is output notebook. It's like a helper function to actually be able to output stuff into the notebook. So the first thing we're going to do after we set up the to be usable within the notebook. First thing we're going to do is we're going to do some pre-processing, and basically we're just going to drop everything that is that doesn't have a class, because I mainly want to be able to visualize the class. So like this, I'm going to drop the subset, and I'm going to drop them, but also what I want to do is like just get the thing that I need. So I need the X, I need the Y, I need the class, and that's pretty much that. If I have this, I'm good. And then I need to create my data source. Right. So I'm just going to jam it into my column data source that I imported here. Put my plot data frame in there, and then I'm going to map the class to the palette of color I'm going to use to the things that will tell it which is which color. A bit convoluted, but basically I want like the different class to be different color in my plot. It's kind of this. So this thing category 20-4 is just like some colors that I found that was cute. So we're gonna use that, and then the different color will be mapped from the class to the data points basically, and then that. Perfect. This should be good. Okay, didn't crash. Now we're actually gonna do some plotting. Figure, and then put the title UMAP on image of world tour. Yeah, we put the width to be 1000 and the height to be 800. That's it for that. And finally, I can actually use something. So the type of plot I'm going to use here is a circle, because it makes some nice circle that I can hover on. And I'm going to give it the source. Going to give it the color mapper. And then just some transparency here, 0.6, filling 0.6 also, and the size I'm going to put it to like 10. Now I can show the plot figure. Should be good. Okay, there we go. So this is what we can see now with this particular plot. We see that there's a cluster over there, and then there's a cluster down there. One thing that we're not seeing is we cannot hover over the dot to see the image, which is something I actually want to do. So we're gonna go back up, right? And when we're gonna extract image, we're gonna jam it into our data frame as a PNG, and then we'll be able to see it with some kind of bokeh magic here. So we're gonna go up here. We're gonna need a bunch of stuff here. So one of the things that we're gonna need is from IO import bytes IO, and import how's it called, this thing? It's called base64. So the only thing we're gonna do is as the image is open, we're gonna encode it. We're gonna create a byte stream, encode it into the format that we want, and jam it into a variable, which we're gonna jam back into our little vectors data here in our dictionary. So how it will look like is like this. We're gonna create that, and then we're gonna create the image in PNG. We're going to also resize it and then store it to a variable with the right encoding. Remember, we have JPEG, so now we're going to put it into PNG. So we're going to resize it, and the size, we're going to resize it, and the size we're going to use is just a thumbnail size, something easy like this. And then so we resize the image, and then we're gonna save it into the buffer stream. The format we're gonna use is PNG, and at this point in time we can put it back into the right variable by encoding it properly. It's gonna look arbitrary what I'm doing, but like these when you encode something, the image, you need to be in an exact format, especially the header. Otherwise, like the system don't know what is the stuff. It's basically going to be a long string. We're going to see it into the data frame. It just need to look exactly like this. I'm going to use our little base64 library, base64 encode. It's called buffer.getValue, and then we're going to decode it. This dic and I made a whole bunch of mistakes. 64. That should be good. And did we make a mistake? No. Okay, cool. Perfect. So now we have that. We did nothing with it, right? We're going to actually put it here. So image, PNG. Put it there, right? Remember, this is our dictionary that we're iterating. And we're building a dictionary, putting to the list. I don't like this. I hate when this is hard coded. So I'm just going to put it here. Let's say like thumbnail size equal that. And then I can just put the thumbnail size. Why I'm doing this, because sometimes you want to change it and it's easier if it's all in at the top, if it's just experimental variable. So yeah, so that should be good. We're gonna let this run. You see here this weird thing. This is actually my image. So this is the header and this is the base 64 encoded image, which is going to be just a bunch of characters. It's a whole string of characters. And that's it. I can skip a bunch of stuff now because like I don't need to run all of the stuff. But if I go back down here, now I can actually just extract. Yeah, I can extract the image, and then I can actually use the image in my plot. Okay, so now again, it will look a bit weird because we're using some JavaScript magic. Every time that you're using like some special library that is kind of JavaScripty in a notebook, it will look like complete garbage in the code. But yeah, I decided to use it, so we're gonna stick to it. So what we have to do is add to the plot figure the tools that we want, and the tools is the thing that I've imported over here, which is the over tool. And what's gonna happen is we're gonna as we're hovering through it, I want the image to appear. So we're gonna have some cute, very cute HTML straight into this. It's gonna be beautiful, right? So those that don't know HTML, usually when you're doing data science, especially except if you're doing web scraping, you don't actually need to know much. So here I'm gonna have an image, and the source of my image will be like @image. The @image thing is important because the @image is something I'm gonna give here. See this? And this is the thing that it's literally the whole image encoded that I'm given. So I'm gonna put it into the HTML here. The style will be float left margin 5 pixel, 5 pixel, 5 pixel, 5 pixel. Yeah, that's what I want to do, and then I can close that. It's very annoying to add HTML straight into a notebook, but yeah. So color will be, if all of this looks arbitrary, because it is arbitrary. Yeah, I tested it before so that it looked cool, but yeah. Font size 12 pixel, and then here we're gonna put the actual class, so that when we're gonna over through it, we're gonna see the image, but we're also gonna see the glass. And that should be good. There's 100% sure an error in there. Why? And why is it doing this? I got that issue last time. I think I need to run everything. Okay. Yes, okay, so let's run that. And that. And that should be cool. Okay. Yes. Okay. Moment of truth. Ooh, we got it. Look at this. So now we can actually explore. So what we see here, maybe it's not the best parameters that I've chosen. Maybe like, what I choose here, the number, what if I put it to 100? Yeah, maybe it's not the best parameter because it will be a bit different depending on what you choose. But we see that there's a cluster here, and way there there's another cluster, and you can kind of understand what the heck is happening. You see here, like all of them are from the same kind of data set. They have a specific hue, a specific color scheme, a specific positioning, and here you have something from another data set. This is what I was explaining at the beginning. This whole data set that is in this notebook is actually 3 different that they put together. And the rationale here was that if we put 3 data sets that are different together with a similar type of label, then the machine learning system will be able to better understand what the heck is happening. I'm not sure it will be much smarter. It's as if like we're gonna train 2 different systems. There's a system here for these ones and system here for these ones. I'm not sure it's gonna know what to crease here. I think it will go like, and like go for this cluster, make some sort of learning here. This cluster, make some sort of learning here. They're way too far apart to be that useful, and we don't have that much data so they can generalize that much. Yeah. So I have run it again with 100 neighbor just so that you can see how it's different. So take a mental model here. It will be a bit different. Should be. You see? So like the number of neighbor like will make it more dense or not. Right now it's a bit denser between these 2 clusters, but it's the same thing. Like these 2 are way too far apart. So actually we want to look at, we want to look at these in alone and then these alone. So if we look here, the orange are scratches, right? And see there's 2 kind of group of scratch. There's these one and there's these ones. And I suppose, I think they're from 2 different data sets too. Yeah, I think they are. And it's the different poses. Or maybe not. This one I'm not too sure. Seems to be like 2 different sort of scratch depending on the image. And then all the blue ones are like all damages. There seems to be a whole lot of different type of damage that you can have. And then the last one here are like the creases. I think they're missing one, which are the dot. Yeah, these one are dot. This one are dot, and I don't have any dot over there. No, I don't. Yeah. So that's it. So that's the whole thing. Honestly, it's pretty cool to be able to kind of look around in 2D or 3D space, depending on what you want to do, and starting from a whole bunch of images and actually like project this down to how similar they are, because as you've seen, like we were able to single out like the different data set with no prior information injected into the model. Like it just looked at the ResNet just looked at the image, and in its embedding it was able to kind of separate them, and then with the UMAP in this manifold space we were able to bring it down to 2D space. And in this 2D space it was very obvious that these 2 things are these data sets are very far apart. It tells you a whole bunch of stuff, so meaning that if they were more together and it was a bit more separated into like the type of classes, you know it's going to be a very simple type of modeling you're going to have to do. But in this particular case, I'm not too confident that adding more dispersed data set will help, because the only thing the model need to do, like I said before, is to kind of separate this learning for the 2 set of images. So I hope this was useful. If you have any question, let me know, and the code is in the description. So have a great week.